And so the next talk is not scheduled. Actually, next talk is it's right now. Actually, sorry, I've missed reading my own schedule. So we now have a talk from Mohammad Hefny, and I can see you're here, Mohammad. Welcome. And so Mohammad is going to be.
Can you hear me from the mic now? The voice is
yes,
working?
can hear you fine. Yep, excellent. And I love the background. That's great. And really good. So you might like to share that background later. That's nice.
Okay, sure.
So we've got Mohammad is going to be talking about his cloud control system. So over to you, Mohammad.
Okay, thank you. I'm sharing my desktop here now. Okay. My name is Mohammad Hefny. I'm from Cairo, Egypt. I'm very excited to be here to talk about what is called now cloud, ArduPilot Cloud, which is two applications, Android and DroneEngage. I will divide the session between Android and DroneEngage because they are two systems. Let me first start by Android because it is the original system. Actually, our agenda is to talk about Android, design decisions I need to take during my journey in building Android. What features I think is special about Android, DroneEngage as the next step of Android, and that I'm not talking about not only it's not just the telemetry, it's much more. And then we'll finally talk about the roadmap. So let me tell you about a brief history about Android. Android is a system that is mainly depend on using mobile devices in order to act as a companion computer. The original idea is to make is to use the Android mobile so that it is Android UEV, so it is Android. That's the reason of the name. And this application has two modes: the GSS, the ground station mode, and the drone mode. And you need to put one of the mobile on the plane or on the vehicle, whatever it is. And the idea that using the mobile because it is easy instead of building the whole system, because what I'm talking about is all built by me. I mean, I worked solely since 2014. So I'm working here alone now. So I need solutions that minimize the effort and give a usable result. I saw the mobile as a compact board that contains lots of sensors, touch screens, GPS, Wi-Fi, 4G, etc. And all of that are compact in one device so that I can use it as a companion computer. Especially, I can use some special features in it, such as SMS and flashlight, so that when the plane is lost, it can send SMS of the last location, and it can turn on the speaker to make a siren as an alert. So I'm making use of the mobile itself. Besides, it is easy for you. You can go now, for example, to Google Play and just download Android. Make sure that you are downloading Android AB, which is Android ArduPilot. This is a new one. So it is, as we see, it is easy. You just need to install it in two devices, and that's it. You have a companion computer and a ground station at the same time. The design decisions I make as a person, it took me easier. Instead of building just a complex board, I choose to use a mobile ground station and run mode are both in the same application to encourage users to download one application and test it, so it is easier than installing two applications and configure two applications. Android has, by the way, its own protocol, which is this section. multi-platform. Originally, Android purpose was to, for example, there is a video on internet on YouTube about Android where I connect the MultiWii and the ArduPilot using the same application, and I can monitor them from the same ground station, and I make abstract flight mode so that I can map between them. That's why I didn't use the Mavlink, and I chose to use a special protocol for Android. And it was based on JSON, so that it is easier to debug in JavaScript and in Java and in Python and in Node.js, which is the technologies that I used to build Android at the beginning. Now I focus. Now I focus on ArduPilot only, because this is I came to conclusions that it's better, and it is ArduPilot is, it's very powerful, and I don't need to I need to focus on some one technology so that I can make the best of it. Make the best of it. So I focus now on ArduPilot. Python, by the way, is replaced by Node.js on the servers, and I focus now on web interface more than mobile ground station, because people ask me to develop a ground station application for iPhone, which I don't know how to develop it. So I decided to move to web, which is a good choice, because maybe if I use native React, I can design different interfaces for different platforms easily. But right now, I just use React, and it is a simple web client. Let us go through some screens here to see what Android. So as we see here, Android is just one application, and you can select between the two modes. You just need to click here to switch the screen between a ground station and a drone mode. The Android itself, it can connect to the flight control board using different ways of connection. You can use Bluetooth, UDP, TCP, serial port via USB. On the other side, Android ground station can support a telemetry feature, which is very nice, because you can connect, you can use the two mobiles as a way to communicate between mission planner or Q ground control with the ArduPilot board. And there is, by the way, a nice video on internet about a friend of mine who was in LA in USA, and he was actually driving my own rover in my own apartment here in Cairo, Egypt, using this version of Android, which is, by the way, old now. Right now, there is more updates. This is still screens from Android ground station. As we can see, there are some SOS options. I can press flash so that the drone application, the Android drone mode on the vehicle, its screen will flash on and off, so that I can find a lost vehicle in the dark, or I can use a whistle or a siren. I can use SMS, but sadly, because of some Google restrictions, they no longer are no longer allowed to put this feature on the drone. I need to be a famous company to re-enable this, but I can enable it if you download the APK directly. Okay, this is the Android screen. By the way, Android can stream video, and by the way, also a ground station, you can monitor multiple drones at the same time, and control multiple drones at the same time, and receiving video from multiple drones at the same time. The videos that is the protocol or the technologies that I use for video streaming is WebRTC. Okay, Now I'm going about the structure of the Android system. And I want to distinguish between the Android app and the remaining parts. And we will see later why. For example, should I use full screen, or it is okay to use this size of screen?
No, it's very clear, no problem.
Oh, okay, okay. So the Android consists of the Android application, which is the Android application that run on the phone. And there is another Android application run on another phone and in GCS mode. As we saw here, it is the same application. I just need to click this button and it will switch to a ground station mode. There is also the web interface that I can connect. This is the web interface, by the way. So I can use the web interface to control the drone. The server is simply two modules that are developed in Node.js. The Android authenticator, which is simply I send a passcode, username and password, and it will target me to a communication server. The communication server is simply similar to a chat room. It's similar to a chat room. The same I use here a username and password, and I use here the same username and password. So every account is directed to the same Android communication server. By the way, I can use multiple Android communication server, and the Android authenticator server can make load balance between them by redirecting each new connection, each new account connection, each new account, because the same accounts should run on the same server. Each new account to another Android communication server, and it also handles when this server is down, it can redirect the traffic to another server. But there is no magic in this part. Is just there is by the way a database here, but it's very simple. Just username and password, currently not encrypted, because I generate the password. I mean, you enter your username and you get a passcode. That by the way you can share it with your friend. You can give it to your friend, and he can monitor you flying from his home while you are in the field. So as I said, it is Android authenticator server, Android communicator, Android application, and the ground stations that is can be Android or a web client. So what is special here, as I talked to you here, the special features about Android? Well, in my opinion, the best feature about Android is that traffic optimization, because Android function is to be used as a telemetry for mission planner, a 4G telemetry. So I had to select the messages that should be sent and select the rate that should be sent, so that because it is not useful, in my opinion, to see the update of a drone 10 times per second. I mean, it is good if I have enough bandwidth, but if I don't, then maybe 2 times per second, it's okay. And other parameters, for example, pitch and roll, it's not very important to have a high rate of it. So traffic optimization is crucial feature for Android. Of course, video streaming. Android, by the way, is capable of streaming video, recording video on the ground station and on the drone application, drone mobile. But on the drone mobile, it is not working in all models, but it works. It also capable of taking screenshots and send it back to the ground station and store another version on the Android drone tagged with the location of the image. I guess this is a feature that a friend of mine also in US told me it is useful. So maybe people in US can correct me that you are not allowed to fly beyond line of sight. So if you have a drone, you can have someone in the field, and this someone has a transmitter in his hand, and back in the office or in your home, you have Android and you are controlling the plane. But the man in the field can choose a channel, for example, an unused channel in his remote control. And when he turns it on, it will block Android on the Android, whether this signal as stop obeying remote ground station and just obey the transmitter. So it is as Android is paused until this channel is released. So I guess this is useful feature for some places. Android web plugin telemetry. This is a very also nice feature because you don't, in this screen, if you want to use Android as a telemetry, you need another mobile. You need a mobile on the plane or on the vehicle and another mobile in your hand, which is a ground station, and you use it as a telemetry. But if you are using a computer only, then you can run Android Mission Planner or whatever ground station, and then run a web plugin, which is a web plugin is just a Node.js application. You can download it using npm command, and you can run it next to the Android website here. This is Android website. It is, by the way, now on cloud.ardupilot.org. So this is Android website. I can run Android web plugin, and this website will stream the traffic to Mission Planner directly without the need of a second mobile. As I said, that I'm focusing on enhancing this website more than enhancing the ground control station on the mobile. Another feature is the gamepad for web. As I said in the first part of the video, that there is a video of my friend in USA driving my rover here using the joystick from Mission Planner. But I said that was an old version, because the new version, you can already use Xbox joystick directly from website and control your drone. And by the way, the control of the drone is not just sending the joystick. It's not just joystick override. It's not RC channel override, but in guided mode. And based on the yesterday session in guided mode, I use the command that I told the drone to move forward in X, Y, Z with a certain velocity, so that it gives me better control. Again, there is a geofencing. Geofencing is, geofencing is part of ArduPilot ecosystem, but there is another geosystem here, geofencing here. Sorry, there is another geofencing here can be implemented by the Android itself, the companion board itself. You can define regions, and the sync part is that you can define missions in Android, and these missions you can sync between two drones. And there is a video on YouTube channel. My YouTube channel shows that there are two drones, and these two drones are waiting for each other. When the first drone reaches waypoint 1, it waits for the other drone to reach waypoint 1 before proceeding together to waypoint 2. Then again, the next drone is waiting for the first drone. I implemented that by I use the missions inside the ArduPilot system, but the synchronization part is done like the following. I use an unused servo channel and I store a value. This value represent PWM signal, but actually this is what it should mean. But what I use it for, I use it as an event ID. So when I reach point A, the next order in the mission planner is to set the servo channel number N to value X, which is an event. So when it is set on Drive or DroneEngage, receives this as a firing event, and it sends a message to it broadcasts a message to all drones on the system, and the other drone receives it, and he knows that he is waiting for this type of event. How? Because he is using another servo channel. There are examples, for example, servo channel number, for example, 10 and 11. So servo channel number 10 is for firing event. Servo channel number 11 is for waiting for an event. So that's how I combine the mission planner, the mission planning inside ArduPilot and the synchronization. Yesterday I was talking with Trijel about that maybe we can use some sort of a register inside a mission planner rather than using a servo channel. I mean, it's a way of storing value, and then maybe sending it. It's a way of communication and exchanging events between different drones. It's just a proposal from me. As I said, because it is a mobile, it can send SMS, and it can use a flash screen, and it can flash its screen, and it can use a speaker. So this is how, by the way, this is actual images of users who used Android. This is not my stuff. This is how they mount the drone, the mobile under the quadcopter, and this is another picture shows how they mount the phone on the fixed wing. As we can see here, that the cameras use a device to reflect the image so that it can point forward instead of facing the ground. As the other solution here shows that it is not aerodynamic friendly to install the system like that, and that's why I moved to DroneEngage. So if you have questions before I talk about DroneEngage. Okay. DroneEngage. This is.
Sorry, I just have one. Sorry, sure. I said one question. Back on the slide 7, I guess.
Okay.
So is this? I didn't quite understand. Is this authentication? Is that running on like some of your own
yes,
servers?
Let me enter here the cloud. ArduPilot.org. You can see this screen, right? Okay.
So are these your servers? Are these like, or ArduPilot servers maybe? Or are these like Google?
No, this is ArduPilot server.
Cool.
So root at. Okay, BM2 list. This is Android. Okay, this is the Android authenticator, and this is Android server, and this is the website. So if we go here, Android server is or an Android authenticator is just a Node.js application, simple Node.js application, just receive HTTP connection with login requests, and it communicates with the Android server, one or more. By the way, Android server can run on different machines so that we can use different machines. But here in this case, we are using only one machine. This is Android server. Again, it is just a simple application, just Node.js. And last, this is the website. That's it. By the way, you can run this local, and you can run this. And what I mean by local is not only on your machine. I mean, it is useful for some people in areas where there is no mobile coverage, but they have the long-range Wi-Fi, for example. They can have their solution and run it. And by the way, it can run on simple Raspberry Pi 4. You can run this server on very simple hardware.
Okay, great, thanks. Yeah, I just wanted to clarify that dependency. That's great, thanks.
You're welcome. So about DroneEngage, the big issue about Android is that two things. The first thing is that people ask it, they need a camera that is not fixed like that. As we see, it is a very nice, a very nice application in my opinion. But maybe it is useful for boats. By the way, some people use it in boats, and can see that in the discussion on ArduPilot. Some people use it in boat, and on rover, for example, also, because there is no aerodynamic restriction. But on drones, it is heavier, and it is as we can see, it's not aerodynamic friendly. So people started to ask if I can put it inside the plane and have a wire connected to the USB of the mobile, and then I can use the outside camera, which is fortunately not possible. At least I couldn't make it. So this was a problem. The other problem is that when people start to think of this solution as a business solution, they just reject using mobile. And in the beginning, actually, I honestly, I don't know why, because it is a board. Why should we look at it as a mobile? It is a compact board full of features. If you run it as with root permission, for example, it is a very nice compact board with built-in battery, etc. But again, the camera is a problem. So I thought about building another system, which is DroneEngage. So DroneEngage is not, it is a Linux-based Android system plus, okay? So plus is very important. I mean, it is not just an application that replace this part. It doesn't replace Android application drone only. Why? Okay, first, as I said, it is a phone. This is a problem. Camera cannot be separated from the device. It can be bulky. This is another problem. Running on Android, because of Google updates, as I said, old version of Android was capable of sending SMS. New versions was not, just because Google Play just told me not to.
We appear to have lost it. Other people still online, or is it we lost the link to Mohammad, or if we have a...
Yes. Yeah, I'm here and we've lost him.
All right. Okay. I wonder if it was just me, but I will just ping him and make sure he knows. Mohammad was kind enough. We walked through this yesterday. So, are you back again? Oh, your audio, you just muted. You need to unmute yourself.
Oh,
yeah, now you're back.
Okay. Okay, the internet here is okay. I'm back. So I'm not aware where you lost me. You lost me in when I
About
was
30
talking
seconds
about this
ago,
part.
maybe 30 seconds to a minute.
You were just
Okay.
starting with DroneEngage.
Okay, so DroneEngage, I was talking about that it is the problem that I moved to DroneEngage because it is Android was running on a phone. Camera cannot be separated from the mobile. Mobile is heavy, and Google updates sometimes prevent me from using some features that I used to use, such as the SMS. So that's why I switched it to DroneEngage. And the first version was built actually 2 years, 3 years ago, or maybe more. But it was, I kept it because anyway, it was not powerful enough, and it was in the very first early stages. It was built in Python, Node.js. Later, I converted it to C++, which was a huge step for me because the performance, obviously. But now let me talk about what is DroneEngage, because again, it is not the Python, it's not the Linux version of Android. DroneEngage itself is a system, So I'm talking about this particular part. The other parts are the same.
Hey, Mohammed, can you share your screen again?
Okay. Sorry. Now you can see my screen?
Yeah, that's great. Thanks a lot.
Thank you. I'm sorry. So I'm talking now about DroneEngage. DroneEngage is not a direct replacement of Android application. And I'm DroneEngage. This whole part is only this part. The remaining parts are the same, the very same. I mean, you can even send from DroneEngage and receive from Android ground station. You can do that. So, but what is special about DroneEngage? First, DroneEngage is not just an app. It is multiple apps that communicates via UDP packets on one LAN. So the main app is the communicator, which organizes between different modules, and this communicator is the one that talks to Android authenticator and Android communication server. So this is the core. Then there is another application which integrate or plugin, which is a separate application, by the way. It runs as a separate application that communicates with, for example, Bixhawk or Orange or Opal or whatever board, and it communicates back to communication module. And there is another application which is the video WebRTC, and this application can stream from multiple cameras. And another nice feature about this application is that you can replicate it. For example, you can use another video plugin here and here. What is this on a Raspberry Pi 4, for example, this on another Raspberry Pi 4, this on another Raspberry Pi 4, and this is running on a fourth board, and they are all communicating. And this has its own 4G modem, so that they can stream simultaneously from multiple cameras from different ports, so you don't have even the wide bandwidth problem. So the idea of DroneEngage is that it scales the computation power. It is not only a companion port, a single companion port. It's not that. It is multiple ports that can communicate with each other. You can run these modules together, as we will see later, on single small board, or you can use a PC. Yesterday I demoed a PC on my PC, and I ran these modules. Anyway, so I mean, this is the idea of DroneEngage. It is multiple board. It is multiple language. By the way, you can write the plugin is just the plugin communicates with the communication module using a certain protocol, which is very easy. It's a JSON-based protocol, and it's very easy, very straightforward, and you can write it in Python, in Node.js, and you can define your own messages, so you don't need to have uh, you don't need to have uh, sorry, you don't need to have a knowledge about the internal C++ of this system to build a new plugin. For example, for AI, it's very famous to build a Python-based application, and it's very easy to actually it exists. So again, DroneEngage is a Linux-based Android app running in drone mode. So it replaces only this part. The system runs on Linux, which allow different boards such as RPI, Raspberry Pi, and JSON. JSON Nano, for example. It supports multiple cameras. By the way, also there are videos. I will share this in the discuss or the Discord, so that I will share these videos. You can put multiple cameras on the same board, and there are already videos shows it. It's a board adding more modules, either in the same machines or other machines. I'm repeating myself here because I already mentioned that. Sorry. Okay, the system, the DroneEngage here, as I said, the core component is the communication module, and this module communicates with Android server. Android server is this module, and as I said, Android server is a chatting room. It's simply a chatting room. The difference is that flight control board plugin and the camera part are split now into different modules that can run on different machine. The function of communication module is to receive messages from Android server forwarded to subscribed module. The modules, the plugins you make here, subscribe in this defines just using it uses a simple config file where you can define that you are a module of type camera and you need this type of messages, and you give a camera capability and video capability to the system. It's very easy and very straightforward. And the communication module then receives message from Android server and forward messages between these plugins. Even these plugins can communicate with each other, as we will see very soon. So again, here another important function is that communication module forward message to another modules, subscribe modules will allow inter-module communication. So we are talking about scalable computational power, multiple cameras, and it is compatible with Android. Let me be honest, it's not 100% compatible, but that's because I'm again one person. So I get, when I add here message and then I go back to Android to make sure they are compatible. Sometimes I make some bugs for sure, so that I really, maybe this is in the roadmap. I think being part of ArduPilot will give me a lot of people that will try this test, and a lot of people will help me to test and develop this system to be much more robust. Okay, I'm talking here about the huge system, okay? But this is actually the system in its very basic configuration. And it works, okay? This is a 4G modem. This is a Raspberry Pi 02, and this Raspberry Pi 2, not 0, because 0 doesn't is not powerful enough to run stream camera using WebRTC. At least I didn't made it, but using Raspberry Pi 2 and using this configuration, yes, you can connect this to your Orange or Big Stock or Opal or whatever, and you can control your drone from anywhere. and it is only 35 grams. By the way, I have another image that I put on a balance and I weighted this gear. They are all together, including cables and everything, 35 grams. And on this module, I can run the computation module, the FCB, and the video. For sure, these modules are out of questions. They cannot run on such small boards. Let us hear different architecture, different architecture views. Here there is a big SOC and Raspberry Pi 0 and LG modem. And if you are using a Raspberry Pi 0, you can, but then you cannot use a camera, but you can use a telemetry. You can then run this application quite well, but you cannot use WebRTC. This is how I connected. I don't have Orange, by the way. I use my Obel, but for Orange, you need only to connect it using serial port and to Raspberry Pi, and then use OTG cable to with the this modem to send it to cloud. Using our Obel or any Raspberry Pi based ArduPilot ports. If you have a Raspberry Pi based ArduPilot board, then you can make use of two things. You can make use of the wireless connection, which is, I heard yesterday, it's not the best option, but it is. If you can do it, you can do it. Maybe it's useful also for ESP32. You can integrate via wireless connection, and or you can use an OTG USB to serial and connect here OTG, and this is Opal, and you can use the BXF Mini or whatever Navio or any Linux or Raspberry Pi Linux based board, and then you can connect it via the TXRX of the serial port here, and then use another OTG with the modem and the camera, and that's it. I used here another solution. As I said, I used a wireless connect. This is a MiFi. I'm sure you are aware. MiFi is just a Wi-Fi device and a 4G built-in modem so that it can connect different modules together. I put it at the bottom of my quad, and it connects everything on it. So this is my quad. It's a lot of wires, but it works. So now let's talk about the communication. I want to mention how can we communicate between these modules. It's like that. The web client send a message to internet server forward message to communication module. Communication module found that this message is a command, for example, ARM. So the FCB controller is subscribed in the ARM command, so it will receive this message, and then FCB will reply to communicator, and it goes until the website is updated. But now let's go, for example, in the camera scenario. In the camera scenario, we have multiple boards and multiple cameras on multiple boards. So every board need to have a useful name. For example, a board camera called left wing camera, right wing camera, rear camera, etc. And each camera is connected to a board as /dev/video0. So there should be a mechanism here that allow naming these these cameras to useful names that is meaning and readable to human. And then when it receives a command from web, it forwards the command to the correct board that holds the correct camera. And each board of each application can handle multiple cameras inside it. There is one thing here. Here it is a screen that shows that when I press camera, it displays multiple cameras so that I can select which one to stream. And I can select, by the way, multiple. I can stream for multiple. cameras at the same time. This is another way of the intermodule communication. The same story, but here, for example, the AI module YOLO sends that it detects an object to communicator module. Communicator module sends to the web. The web display the boxes around the objects on the video, and the user sent back that I want to track this. Then the communicator module receives this command and sends it to the tracker. The tracker tracks the image and give XY offset. So it sends it back to the communicator that is sent it back to the flight control module to update the behavior of the vehicle to keep track of the object. This is how the intermodule communication happen. And as I said, this is on this part only is on Wi-Fi, so it is very fast. Okay, that's it. This is everything. I only can show you a video, a sample here. I will connect from Android. By the way, if you want, you can connect to this website now. I will send it to you. By the I'm not sure how many will be able to connect, but I hope it will connect. It will ask for username and it will ask for password. If you connect, now I will connect my drone, an SITL. I'm running, my mobile now is connected to the SITL. As you can see, this is the drone and it has a mission. I can press guided mode, I can arm and climb. It will take off. Go to mode. I hope you can see from here. Now I will run another module. Can you see from here? This is Android and this is run from my mobile, okay? And the other is Yavuz and it is running from this, as we can see, DroneEngage Communicator Pro. So I'm running two SITL and they're running together and I can control each one of them. One of them is running Android and the other is running DroneEngage. So the systems are compatible. What I'm talking is that in the ground station Android, it is not very compatible. I'm not sure if I can use here text. Okay, guided mode. I can use here a joystick here and I can try. As you can see, the channels are converted and I need to set this in the config file of the system. I'm pressing, it should go backward instead of forward, but it is a configuration file that I need to reverse. As you can see, I just connect. It is not, I'm talking to the web here and the web is talking via internet. Also, I'm making the demo on the same machine, but they are not talking directly. This is not a local server. I'm connected to the internet and it talks through this structure. It goes from here to here to here and to here. This is a web communicator and this is a ground station. This is a drone. This is a vehicle. So I'm now executing this sequence diagram. So that's all. If you can connect, if you wish, to the system online to see these drones connected right now, and you can take control. Don't worry to play with it. You can download the system. The system is available on GitHub. You can download it straightforward and you can run it. You can download the Android application from Google Play and just connect it to SITL and use it straightforward. Okay, if you have any questions.
It's pretty cool. I just switched into RTL and off it went.
We have a couple of questions from the chat. One of them was whether or not you're using a VPN for the communications.
No, I'm not using VPN. It is HTTPS connections to direct internet, no VPN.
Nice.
And so the telemetry is over HTTPS as well?
Yes, the telemetry is over HTTPS.
Yep, okay. Cool.
I suppose I wanted to add encryption capabilities, but that I used some or in the beginning many years ago, but now I disabled it. Maybe this is also part of the roadmap is to encrypt the messages. But I'm using HTTPS and the WebRTC. I'm using just a turn server that exists on the cloud ArduPilot itself. So the capabilities, the overall capability of the system depend on this virtual machine. Of course, you can scale it. So, any other question?
So I should say that Mohammad was kind enough to give me a personal demo of this the other day. And one of the things we did that was those little telem off button, we used that to forward telemetry. So we were using the web client, which is the one you're seeing on the screen now. And then you can tell it to forward telemetry locally. Then I was able to connect Mav Proxy and Mission Planner locally. So I could have all this cloud stuff running with the camera feed and that control. But then if I need more direct control, where I need some capability that's not in this interface, then you can use that telem off button to turn on telemetry and get that a real Mavlink feed, not the JSON feed locally. And I did check in, it is Mavlink 2. It's doing all the Mavlink 2 fields connected to my case Mav Proxy, which I then forwarded further on to Mission Planner. So even though it's all being transmitted over JSON, it can back translate that into Mavlink locally for use of a more traditional ground station, which I think is a very neat feature.
Thank you. I also I must mention that I'm using two types of JSON. The JSON, the text-based JSON, which is the normal, and then I use another type of mixed hybrid message, which is a JSON header, and then I attach a binary bar. So, and this is how I use an encapsulation message for Mavlink. I can forward Mavlink using just a text of formation of JSON just for routing the message, and then I attach the binary part itself without converting to any other format. It is binary and it's sent through the system. I want to highlight only a small feature here that I can download the parameters, which is not big, but it is not possible to download it from Android. It is possible to download it from DroneEngage. This is one of the differences between this system. Why? Because again, I am single developer, so maybe this feature will be added to both. I think it's added to both. And that's it. Thank you. So if you have any other questions.
Yeah. Is it open source or some parts open, or is it?
No, it is open source. You can find it on GitHub. I think only I'm preparing Android part to Android part is already shared with Trigel and
Yeah,
sorry, shared with some person with Trigel here, and I'm will make it open maybe after this demo, and other parts are open. For example, this part is open, this part is open, the server part is open. this part is open, this part is open. Drone is a web client, the website is open, the web plugin is open, so you can build the whole system. And as I said, I'm happy to share it with the community, because actually it's better to make use of many people and update the system by many people with many ideas, so that it is getting powerful, and this is what I aim to.
Really impressive, and it does a lot of things that people want. So yeah, if it's open, you should get some good uptake from the community, I would have thought, and from companies as well, you know, and pro users. It's really great.
Thank you very much. I appreciate it. Thank you. So it's thank you for your time, and I'm really honored to make this presentation and take this chance to present these systems. Thank you very much.
Fantastic. Thank you so much, Mohammad. That's absolutely brilliant presentation. Really appreciate it. And thank you for all the work you've done on that, that project. And I hope that this talk will inspire you to get a lot more people testing this system.
Yes, that's what
So let's see. So if you could stop your screen share there now, I'll just, actually, I can do that for you. That's done. So I will now just share my screen and just show the schedule where we're coming into the closing part of the conference now. And so I'll just share my screen here so we can see the last part of the schedule. So this is the stage we're up to now. We've just had Mohammed's talk about cloud control. We've now got a gap, and we're due to come back at 7 p.m. Canberra time, which is in 5 hours time. So we have a 5-hour gap now. And so get time to have your lunch or dinner or breakfast or whatever it is for your time zone. And then we've got the 2 final presentations, one by Sid, DroneCan and CanFD update. And then we've got Pete Hall giving tail sitter developments. And finally, we've got the dev team discussions about the roadmap and what we're going to be doing over the next year. So thank you to all the speakers who presented in this session today, and look forward to seeing you all again in 5 hours' time.
Catch you later.
Thanks, everyone. Right, bye.
Bye.